Hello, everyone, and thank you for joining us for today's session. My name is Iskia, and I am one of the event planners for the Redmond Reactor. And before we get started today, I've got a few things to go over. So if you could please take a moment and read our code of conduct, which we've also posted in the chat. And basically what that is saying is that we seek to provide a respectful environment for both our audience and presenters. We encourage engagement in the chat, but we ask that you please be mindful of your commentary, remain professional, and when possible, please try to stay on topic. We're going to be sharing useful links throughout the chat, so please keep an eye out for that. And we want to let you know that this session will be recorded and is going to be available on demand in about 24 to 48 hours, and that can be viewed on the Microsoft Reactor YouTube channel. That brings us to today's session. It's scheduled to run approximately for 30 minutes, and we'll have time for questions throughout. So with that said, I'd like to hand it over to our speaker, Prashant, for introductions.
Thank you, Askia, and thanks everyone for joining us today. The title of this talk is Building Multimodal Application Using Generative AI. I am from Washington, D.C. area, and I currently work as an AI architect in the Office of CTO at Applied Information Sciences. And I have been focusing on AI agents and agentic AI from last year. And before that, most of my time was spent on working on applied AI since 2017. And these are my contact details in case you have any follow-up questions after this talk. So let's talk about what is generative AI. So generative AI is a form of AI that learns a digital representation of artifacts from sample data and uses it to generate a new original realistic artifacts that retain likeliness to the training data, but it don't repeat it. Generative AI is multimodal. It can take different forms. We can use it for text generation, summarization, completion, translation. We can also use it for visual generation, editing, translation, or style transfer. We can also use it for speech synthesis, music generation, and now recently we also now have video support as well. So we can use generative AI for generating videos or editing videos as well. So before we dive into some of the multimodal aspects of the generative AI, let's focus on how exactly the foundational models of this generative AI are built. I'm giving you an example of GPT-4 model here, but the same principles can be applied to other models as well. For example, during the training phase, these models will go through the entire data set that is accessible to them. In case of GPT-4, it actually went through the entire data set that was publicly accessible. It can be books, website, journals, Wikipedia, code entries. And then after training, they created something called a transformer model. Again, this is an example of GPT-4, but the same principles can be applied, can be used for other transformer models as well. And these generative AI models are very good in adaptation. Like for example, GPT-4 is really good in terms of following instruction, brainstorming, wordsmith, summarization, extracting content, answering questions, classification, translation, code generation, code explanation, code refactoring, code debugging, and you can name it. So these models are excellent diverse set of tasks. And another thing is we can consume this large language model as an API. Or we can also use it directly, like integrated with off-the-shelf products like ChatGPT app or a Microsoft Copilot app. But along with that, if you're a developer, you can also consume this large language model as an API, and that's where the real power of this large language model comes into picture. Where since these models are available as an API, then we can start integrating it in your custom applications. Another thing is, out of the box, this foundational large language model does not have insight on your organizational data unless you explicitly provide that. But most of these models, especially if you're taking example of GPT-4, it doesn't have any insight of your organizational data. So out of the box, so you have to do some additional steps to bring your organizational data to the large language model so you can use it for generative applications. So to get maximum value out of this large language model or to build multimodal application, one thing that you really need to master is prompt engineering. So prompt engineering is a concept in natural language that involves embedding description of task in input to prompt the model to output the desired results. And using prompts, we can do text to text interaction. Like for example, I can ask the large language model, what is the largest ocean in the world? And it can come back with an answer like, hey, Pacific Ocean is the largest. We can also provide the prompts to generate the image as well. That means multimodal text to image. I can give a prompt like, hey, a close up, a look of a cute raccoon walking through the forest, photorealistic texture and lighting. And this is similar to this image that the model will generate. I can also provide both, where I provide text and image, and I ask it to describe for you. For example, what is on this image? So if I use this image and upload this to give it to the large language model, it can then digest the contents of the image and then basically describe this image for me. So since these are the capabilities available with this large language models, we can now take it a step further, and then can really create a lot of creative enterprise application using this multimodality feature of a large language model. So now, if you once and to do that, we have to consume this large language model as an API, and there we have a concept called a system message. A system message basically provides the model additional context to generate a response, and this is like a sample prompt where we have a really good system message, and like for example. Um, in the system message, we can specify the various tasks we want the large language model to perform. We can also give some rules and validation. We can also input some safety techniques and some jailbreaking techniques as well. And this is once we provide that, and then depending on what user provides as an input prompt, then the large language model will respond with the respective answer. So what kind of applications we can build with large language models? So one is we all have seen Copilot, which basically a UI for AI. So if you are using ChatGPT as an app, or if you're using Microsoft Copilot as an app, or if you're using GitHub Copilot, that is a good example of Copilot, which basically is your personal AI assistant for work. Now we can also use generative AI for creating agents. And agents are nothing but AI powered system with action, triggers, and knowledge. Like for example, if I look at the Copilot, in Copilot, if I go to ChatGPT, I can ask it to give me some information. I can go to the Microsoft Copilot. Same thing I can do there. I can ask it to create a draft email for me, or generate some content for me, or do a research for me. But Microsoft Copilot out of the box will not let you take any action. For example, once a draft email is done, I cannot really tell it to, hey, like, send the email to 50 users or these 5 users. To do that, you have to create agents, and agents actually works on the behalf of employees, teams, and function. And Your agents can be connected to the Copilot, or it can be autonomous as well. For example, I can have my agents running on a schedule, or I can also run my agents on a specific trigger. For example, as soon as a certain activity is done in SQL, or any record is updated in SQL, start the agent and then do further processing. Or as soon as a new email comes, then digest the content of the email and then take appropriate action. So a lot of things we can do, but these are the two predominant application we can create. One is the Copilot, which is UI for AI, and second is the agents, which is basically you're using. Okay, I see a question from what is the LLM behind all this multimodal stuff? The name of the model that we'll be using is GPT-4. So there are two multimodal models available right now from OpenAI. One is GPT-4o, which is GPT-4o Omni, and second is GPT-4 Real-Time API that also has support for voice as well. So now let's see. In the beginning of the talk, I mentioned the foundational large language model doesn't have access to your in organization data. Then how you can bring that data to the large language model? And to do that, you have to use a technique called retrieval augmented generation, where whenever a user is sending a system prompt, sorry, a user prompt or a question, instead of sending that question directly to the large language model, we're basically retrieving the data from your organizational knowledge store. Like for example, first retrieve the related information about that question from my organizational data, then add that to add the results to the prompt, and then send that prompt to the model. And whatever the response will come from the model will then show that to the end user. So this is like a quick and easy way where you can address that knowledge gap, where you can bring your organizational data in a secure and safe way to the large language model, and then get the answers or get specific things that you're looking for from your organizational data over there. Now, how to use large language models in Azure AI. So in Azure AI, we have a service called Azure AI Foundry, which gives you a unified access to all the services you need to create your generative AI application. It has a model catalog where more than 1900 models are available. You can use models from OpenAI, you can use models from Microsoft, from Mistral, from Llama, Hugging Face. Lots and lots of models are available there. Uh, you can also some of the models are also available for you to fine tune. That means you can take off the shelf models, and you can also modify its behavior by providing your training data. Along with that, Foundry also give you access to Azure AI content safety. If you would like to implement any guardrails or any kind of safety measures as part of your generative AI workload, you can do that. They also have a service, Azure AI Agent Service, to create agentic AI. Azure AI Search is also there in case you would like to vectorize your content and then surface that via Azure AI Search. This service is also available, and of course, the flagship app Azure OpenAI service is also there. Along with that, you also have evaluation, and monitoring, and Azure AI Foundry also have Azure AI Foundry SDK. So not only you can use Azure AI Foundry portal, but you can also use SDK to automate your deployment pipeline. Any workload that you're creating using Azure AI Foundry, you can consume that, from Copilot Studio. You can also write application using Visual Studio, or you can start your journey with GitHub as well. So you can start anywhere, and you can then port your applications over there. And I see that the best way to submit the question, I see a comment there, is just submit in the chat, and I will be monitoring that, and then periodically answering those. There is a question regarding slides. Yes, I can provide the slides. So towards the end, we'll be providing my contact information. Just feel free to reach out to me, and I will provide you the copy of the slides. And I didn't get the last question, which is some comments, please. Can you elaborate more, in terms of what those comments means? What does that mean? Okay. So next up is I'm going to show you a demo of a voice RAG, where what we'll be doing is we will be using the multimodality feature of generative AI, and we'll use that to create a voice-based app to get answers from organizational data. And this is like the high-level architecture of it looks like. The front end is built in React, and the back end we are using it uh, backend, we are using it, the Azure OpenAI real-time API, and for our knowledge store, we are using Azure AI Search. And this is a very simple application that we will be demonstrating today. So what we have done is we have ingested all the employee benefit information. For example, this is a typical employee benefit information looks like, and again, this is all made up content for Contoso Electronics. And this has some health insurance plan, like what is going to be my premium for, let's say, doctor's visit, for dental visit, emergency visits. So all this information are there, along with some additional data here. So for example, I have employee handbook. I also have a benefit for another company as well. And what we have done is we have indexed that into the Azure AI Search. Okay, and from this React app, when a user start communicating with this app, the user can ask questions about the health benefits, and then the first thing it's going to do is go to the Azure AI Search, retrieve the relevant content, and then send that to the Azure OpenAI real-time API, so that it can give you the corresponding the answer back. Again, this Azure OpenAI real-time API is very, very powerful. It supports multiple languages, and in the single conversation, I can also switch the language as well. And uh, We'll be also posting the link to this particular demo. So the entire demo is open source, and you can deploy it in your Azure subscription. Again, you will be needing some assets in Azure, and we'll be sharing that demo which we just posted in the chat, where you can go and it has the step-by-step instruction on how you can then deploy the same demo using the best practices that are available in Azure. So without further ado, what I'll be doing is I'll be quickly showing you the demonstration of this, how exactly this app will look like, and then we will show you some of the other details of the implementation. Right. So now I'm at this app, which I have already deployed. And to begin conversation with this, all I have to do is click on this mic and then start speaking. So I'm just going to refresh this so that, everything is from scratch. And what I'll be doing is I will be start talking to it, and then I'll be asking the question to it. And the model then should respond to me in voice. Hello. Hello. How are you?
I'm doing well, thank you. How about you?
I'm doing good.
I'm glad to hear that.
I need help
Sure.
with the dental insurance information for Contoso Electronics.
Contoso Electronics offers dental insurance through two plans, Northwind Health Plus and Northwind Standard.
Okay, thank you. Can you also explain this in Spanish as well?
Claro, Contoso Electronics ofrece seguro dental a través de dos planes, Northwind Health Plus y Northwind Standard.
Okay, thanks. मुझे आप बता सकते हैं कि इसमें एडिशनल डिटेल्स क्या है?
मुझे खेद है, लेकिन मेरे पास अतिरिक्त जानकारी नहीं है। क्या मैं आपकी किसी और तरह से सहायता कर सकता हूँ?
Thank you. So you can see here now in the single session, I can start interacting with this real-time API model. And also I can change the languages in the same conversation. For example, I started with English, but then immediately ask it to give me answers in Spanish. And later on I start talking with him in Hindi. Like those of you who don't understand, I actually started like talking to in Hindi, and it just quickly understood real time that I'm asking the information in Hindi, and it just came back with the answer for that particular question in Hindi. So this API is really powerful, and this API is available as part of Azure AI. So you can use this API on both sides. You can go to directly to the OpenAI, or you can also go to the Azure AI Foundry and get access to that. So here I'm going to show you inside the Azure AI Foundry. Like if I go to the model catalog, this is where you'll see more than 1900 models are there, but this service is specifically for OpenAI, so that's why only models from OpenAI are listed. And the model that we are use for this one is this one, GPT-4o real-time preview. And I'm just AI Foundry. You can also interact with this model in the playground as well. As long as you have deployed this, you can start interacting with this, and you can choose various voice options. So right now, out of the box, it has this many voices like Alloy, Ash, Ballad, Choral, Echo, Stage, Shimmer, and Verse. And I think it's just a matter of time before some custom voices will also be available. I don't know when that will available, but it's just matter of time where some of the companies like OpenAI will be launching a support for that. Another service that we have used for this is Azure AI Search. And that's where we have ingested all the documents for that. And as I mentioned, the entire application is available open source. So if you go to this particular GitHub repo, here you can go and then find out the description, the architecture diagram, and how you can get started, like how you can run this locally, how let's say you can deploy, let's say using dev containers. First thing first, you need access to Azure and some of the services, especially Azure AI Search. It's a little bit expensive to begin with. So just keep in mind, like this particular solution is going to consume few $100s of Azure credits in a month if you keep it running, and it has a step-by-step instruction in case you would like to use your own pre-provisioned Azure AI services such as real-time API or search service. You can do that as well. And it has information about the pricing, like how exactly it's going to cost, all those stuff. It is there, right? So with that, what I'm going to do is I'm going to pause here and just quickly share my contact details in case anyone has any question, and if you would like to have follow-up conversation. This QR code will directly take you to my uh, a LinkedIn profile, but I have also listed my email address as well. And now I'm just going to use the time to answer any questions that are there. Okay. So when should we fine tune a foundation model? Okay. So that is a great question. The guidance here is there are three techniques you can use to modify the behavior of out of the box foundation model. First is using prompt engineering. That is recommended. Uh, uh, However, it may happen that you had to provide lots and lots of instructions and rules or some additional context so that generative AI can understand it as part of the prompt. So your prompts may be bigger and bigger, get made bigger and bigger, and that may not work in long run. Another technique you can use is something called RAG, where along with prompt engineering, you also use RAG pattern. So that way, you just like retrieving the relevant information and then providing that to the large language model along with your prompts. If that is not going to be helpful for you, then the last option is then going with the fine tuning, because some of these models, such as models from OpenAI, to fine tune them, you have to go through the extensive process of fine tuning them, and you also have to then host those fine tuned model, and that is typically a more time consuming task and laborious task. However, a lot of companies do that, but they would use that as a last resort. Okay. uh, Okay, so the question from how do we achieve the multi-language capabilities? So multi-language capabilities are already available out of the box with this particular model. So you don't have to explicitly do anything on that. However, when it comes to avoiding hallucination, that's where your prompt engineering techniques and your implementation of RAG and some additional techniques come into picture. So there you can use the same techniques that you typically use even with this text-based application. Okay, so what approach to chunking and embedding the data? So for chunking and embedding, we are using, for this particular sample, we are using Azure AI Search. And I think we have used embedding model from OpenAI. Let me quickly show you that. So if I go here, so these are the two models we are using here. One is the GPT-4 real-time preview, and for embeddings, we have used text embedding three large model from OpenAI for converting this document that we have provided into the vectors and storing that into the vector search. All right. The next question is, are these specific multimodal architecture combinations that you have seen work well in production? So far, when it comes to multimodal, text and images are working fine. When it comes to videos and audios, it all depends on how much capacity you have reserved for this, because this the multimodal, like the models which supports audio and video, required a lot of compute behind the scene. So as long as you have a proper infrastructure which is set up in the backend, you can use that. Only another thing is, as far as production is concerned, you have to check real quick whether these models are generally available from OpenAI and Microsoft or not. If it's under preview, that means you should not be using this in production. Okay, the next question is, what are common cost traps when building multimodal application on Azure? So here, I won't see a trap. It just like, just like in this particular blog post, if you go, there is information about the cost, and uh, doing the calculation yourself using Azure pricing calculator. So as an good architect, before you launch any application, especially using AI, you have to do your due diligence in terms of anticipating the cost, because generative AI, if you're running on scale, can get expensive, irrespective of which model you're using. All right. I think with that, we have come to an end to most of the questions that we have. So let me go back to my slides. So once again, thank you very much for everyone joining us today. I hope you found this session useful. And if you have any follow-up question, or if you need access to the slide deck, just either email me or connect with me on LinkedIn. With that, thanks for joining and have a wonderful rest of the day and week.
All right. Thank you so much, Prashant. That was an excellent session. Appreciate everybody tuning in today. And with that said, we would love to get your feedback. If you've got any suggestions or comments, feel free to use the code, the survey link on the screen, and make sure you use the today's event code, which is 24786. Again, that's 24786. I really appreciate your time today, and we look forward to seeing you on the next session.